Hi guys, we're now going to look at past paper questions. Okay, now similarity is when you kind of do the basic C-level questions. They're very straightforward, but some past paper questions can actually be quite tricky. With some of the shapes that are produced, people sometimes get confused with all the information that they're given. So you need to make your own sketches and make sure they are the correct way round with all your correct information in the right place. That's really, really important here to be successful. So let's try this first one. So the flag at each hole on a golf course is coloured red and blue. The diagram below represents a flag. Triangle QRT represents the red section, so that's the kind of bigger triangle, if you like. That's the red section, the darker section in your colour. PQTS represents the blue section. So that's kind of like a rectangle with a slanted bit at the top. That's the blue section. Okay, but we actually within this have now two mathematically similar triangles. So P to R to S, the overall large flag shape, that is the larger triangle, and QRT is a similar triangle, just slightly smaller. And we're given the area of QRT to be 400 centimetres squared. We're asked here to calculate the area, therefore, of PQTS, which is just the blue slanted rectangle section. So what we have to do is we're given a lot of information here, and you probably might be quite confused just now. So that's what I mean, they throw a lot of information at you here. We're going to take this step by step. We're going to draw out a bigger triangle. We're going to draw out a smaller triangle. We're going to mark on the information. We know the area of the smaller triangle. What we really have to do is, there's two stages to this, is calculate the area of the big triangle in total. Then when we have that, we can subtract the smaller triangle area, and that will get us just the blue section. Okay, so first things first, we're going to make drawings for ourselves with the correct letters and the correct values here. Okay, so this can be my big triangle, so that's PRS. That's 30 centimetres here. And the area is what we're trying to figure out. Smaller triangle is Q to R to T, and that vertical height is 24 centimetres. And the area of this is known to us, it's 400 centimetres squared. So the first stage of this is no different to just our area similarity questions. We've got two similar triangles, we know the corresponding lengths, we know the old area, what's the new area. The only difference here is there's just an extra wee bit at the end to get to the final answer. Okay, so once you have your own two triangles drawn, we're going to go through our process. So first of all, we're going to find the length scale factor. So that's going to be the new length divided by the old length. So the one with the unknown divided by the one that you know everything. So new divided by old. So 30 centimetres over 24. And we need to simplify that fraction by dividing everything by 6. So that's going to be 5 over 4. Now, this is an area question, therefore we need the area scale factor next. Area scale factor is the length scale factor squared. Now remember from our lesson on area, you have the choice. If you are comfortable putting a fraction squared into whatever calculator you're using, you don't actually need to do anything else at this stage. But if that's not going to work for you, then you can just square out this fraction. So 5 squared over 4 squared, 25 over 16. But if you're happy to put that fraction in with the squared button and you can do that okay, then you don't need to do anything else at this stage. So the new or the big area is therefore the area scale factor multiplied by old area. So that's going to be 5 over 4 squared multiplied by 400. So now get to your calculator, please. Give me an answer for that. So you will need to use brackets. So bracket 5 divided by 4, close bracket, squared. Make sure the square is outside the bracket, and then times by 400. And the answer is 625 centimetres squared. Now, this is a past paper question. We're not quite done yet. That is the new area. If you remember, that is the overall triangle shape. So the overall golf flag. We know the area of the red section is 400. We're trying to work out what this blue section is here. And that is quite simply the big area take away the small area is going to give us that resultant blue area there. Okay, so that's all we have to do to finalise our answer. So somewhere below when you're working, I'm going to do it to the side. So therefore, area of blue section is 625, take away 400. So that's going to be 225 centimetres squared. And we're finished with that one. Sorry. Okay, let's try the next past paper example. Okay, this is the one I was referring to in the previous video on reversing. Okay, this is the most recent past paper question, Similarity, 2018, I believe. And it wasn't answered very well. So let's have a look at it and make sure that we're better prepared for it. So we've got popcorn boxes, tubs, sold in 2 different size cartons. There you go, cartons. We've got a 16 centimetre height one and a 24 centimetre height one. The small carton is 16 centimetre, says that, and it has a volume of 576 cubic centimetres. So volume (576 centimetres cubed). The larger one has a volume of 1,125 centimetres cubed. So this is a bit odd. We know both the heights and we're given both the volumes, so something's different here. Question A says, show that the 2 cartons are not mathematically similar. Now we've not kind of came across a question like that before. That means we are going to go through the same process as if we did not know this bigger volume. You're going to find the length scale factor between the bigger and the small one. You're going to multiply that volume scale factor cubed by the old volume, and you're going to see, and well, it shouldn't equal this 1125. And then if it doesn't equal 1125, that proves that they're not mathematically similar. So let's do that. So the length scale factor first is going to be the new length divided by the old length, so 24 over 16, which when we simplify that by dividing by 4 is going to be 6 over 4, we divide by 8, sorry, so that's going to be 3 over 2. Volume scale factor is then that cubed. So 9 over 4 it would be. But you can leave it just like that if you want. Big volume or new volume, if these were mathematically similar, is going to be 3 over 2 cubed. Remember to use brackets, times by 576. So brackets, 3 divided by 2, close brackets, cubed. Remember, do cubed, not squared, as I just made a little mistake myself doing that in my calculator, very easy to do, times by 576. Okay, and the answer you get is 1944 centimetres cubed. So your little statement would be, therefore, as 1944, think back to your kind of converse of Pythagoras, as 1944 does not equal 1125, they are not mathematically similar. And that is you proved it. Okay, so in this case you do have to write some sort of statement. So they're not mathematically similar. Okay, so that was okay so far. We have now a part B. Part B says now the large carton is redesigned so that the two cartons are now mathematically similar. And the volume of the redesigned large carton this time is 1,500 cubic centimetres. So this time the height has now changed, or the depth. So now calculate the depth of that redesigned large carton. So I'm going to draw, you don't need to draw it since it's on your page already, but what we have, just to remind ourselves, we've got two tubs here. The smaller carton, the depth or the height was 16 and was a volume of 576. The larger tub, we don't know what the depth is, call it the depth. I would call that the height, but we can call it the depth. But we do know the volume is 1,500. So this is exactly like the reversing volume question that we did in the previous video. Okay, we have to work back the ways now, using the volumes to get the volume scale factor, to get the length scale factor, to then find out what D is. So the volume scale factor was the one with the unknown divided by the known volume. So what did we multiply 576 by to get to 1500? So 1500 divided by 576. So it's always the new one divided by the old, the one with the unknown divided by the one with the known. So do that in your calculators. So that gives you 2.604 ... Now don't touch your calculator, because the most accurate way is we are now going to have to take the cubic root of this thing, and the most accurate way is to leave the whole number in your calculator and just hit cubic root of the answer, if you can do that. If you can't do that, then just do the cubic root of 2.604. But if you can leave it in there and do the cubic root, so I need to do shift function root button, so it's the cubic root of the answer. That gives me a length scale factor of 1.375. Again, leave that number in your calculator, don't round it if you possibly can, so that it stays as accurate as possible. So that means the depth is increased by a factor of 1.375. So what is our new depth? So D is quite simply this 1.375 multiplied by 16. If you've left the full number in your calculator, just hit times by 16 and you'll get the most accurate answer, which is 22.01. And you can round to really whatever you want to there. I would leave it as 22.0 centimeters. That's to three significant figures. Alright, so bit of a tricky question, that one, I think. First of all, proving that they are not mathematically similar, then working backwards to get the depth of new mathematically similar ones. Okay, I've got one more example to show you. I wanted to really show you a good breadth of questions here. So one more to show you, and oh, I've skipped one page. So it looks like this. So a vertical flagpole that is 12 meters high stands at the center of the roof of a tower. So this actually used to be down here, but I moved it up to get out of the way. Just leave it down just now. So vertical flagpole, 12 meters high at the centre of the roof of a tower. That's important, centre. I'll tell you why in a wee second. The tower is a cuboid shaped with a square base. Square base, that's also important, of side 10 metres. At point P on the ground, 20 metres from the base of the tower, the top of the flagpole is just visible, as you can see. Calculate the height of the tower. This doesn't really look like it's similarity, but it is. Look what is formed in this second picture here. We have two similar triangles, right angled triangles. One larger one going down to the bottom and one smaller one using the flagpole up to the tip of it. We don't really have a lot of information here though, so it seems as if we don't have enough information to answer the question, but we do. We know that the length of the flagpole is 12 metres. We're trying to find the height of this tower. We know the length of this is 20. So we need two corresponding lengths in order to be able to work with similarity. So first of all, let's draw out the triangles, then we'll try and figure out what this corresponding length is. So I have my bigger triangle. Sorry, that's a terrible triangle. I'm not accepting that. That's just horrendous. Okay, try again. So big triangle. Oof, not much better. We know it's 20 metres along the bottom. We're trying to find this missing height here. The overall height of the tower. Now we have a smaller triangle which is formed from the vertical height of the flagpole down to the edge of the tower and back to the base. Now we know that the vertical height is 12 metres. So what we need to do is figure out, we need this length along the bottom in order to do this question, don't we? We need the corresponding length here, this little length, which should be getting highlighted right now, but isn't. We need that length there in order to find a length scale factor. It's hidden in information in the first paragraph. Look at it carefully. It stands in the centre of the roof. The roof is a square of side 10 metres. So this, if we look at this first picture, it is a square with side 10 metres, so it's 10 metres in every side of it there. So therefore, if that flagpole is right in the centre, then it is halfway along that 10 metre edge. So therefore that must be 5 metres, the distance between the bottom of the flagpole and the edge of the building. So that hidden distance there is 5 metres. Alright, so it was a bit tricky to try and work that one out there, but you had to look very carefully at each kind of word in that opening paragraph. The tricky bit is getting that number. Now it shouldn't be a problem at all. Length scale factor, new over old. So the unknown is the new shape, the one with the unknown. That's 20 over 5, so that's going to be 4. Okay, so 4 times as big. Height. There's no area here, there's no volume here, none of that. Quite simply, we just take the length scale factor, multiply it by the vertical height of the flagpole, or the old height. So the rest of this is an absolute doddle, so that's 4 times 12, which gives me 48 metres. Okay, so as I say, the hardest part of that was actually being able to get that corresponding side using the information in the paragraph. If you manage to get that, then the rest of the question was okay. And it's 4 marks, so be aware that if you really didn't know what to do there, if you really couldn't get that length, what you are able to do is just state a length. Just say the length is, guess, 10 metres. Okay, if you state that and you do the rest of the question correctly, You won't get the first mark because you haven't got that right length, but you could still get all the rest of the marks. So you could still get 3 out of 4 marks there. So don't just panic and think, if I don't know that, I can't do anything. You are able to just state an answer, state a number, and then use it for the rest of your working, and you'll still get a lot of marks doing it that way. Okay? Now what you need to do is do some practice on past paper questions from your Unit 4 booklet.